Welcome. In this video, I am going to share some of the basic concepts of operational amplifier. So in this video, I am going to tell you the definition and symbol of the operational amplifier, and then we will be seeing what is inside the operational amplifier, and then the packages of operational amplifier, then how the manufacturers are specifying the operational amplifier, and then we will see the open loop configuration of operational amplifier, and then I will do a small demonstration of the open loop configuration using TINKERCAD, and then I will tell you about the closed loop configuration of operational amplifier. And there are two types of closed loop configuration. One is positive feedback and negative feedback, and finally I will share the comparison between the positive feedback and the negative feedback operational amplifier. Definition of operational amplifier. Operational amplifier is a multi-terminal DC coupled high gain electronic voltage amplifier with a differential input and a single-ended output. So the terminals may be more than two, and it is coupled with a DC power supply, and its gain is very high, and it has differential input and a single-ended output. So differential input means it should have two inputs and a single-ended output. Okay. Because of this high gain, it can produce output voltage 1000 times larger than voltage difference between the input. Okay. Operational amplifier is basically referred as OPAMPs, OPAMPs, because it is used to model basic mathematical operations like addition, subtraction, multiplication, division, integration, differentiation in electronic analog computers. So that is the reason why it is named as operational amplifier. Symbol of operational amplifier. The circuit symbol of operational amplifier is triangle, and this is the symbol of operational amplifier, and it is tilted towards right, and this indicates the signal flow. You see, the signal will flow from left to right, and that is one of the reason for this symbol. And it is having 5 terminals. Okay, 2 input terminals named inverting input terminal and non-inverting input terminal, and 1 output terminal, and the other 2 power supply terminal. Okay, positive power supply terminal, negative power supply terminal. This is the symbol of operational amplifier, and this is the IC form of operational amplifier. And this 741C is the part identification number. Okay, and this 2, 3, 4, 7, 6, these are the pin or terminal number for this 741 IC. What is inside operational amplifier? So the operational amplifiers are constructed mostly out of transistors and resistors. So inside the operational amplifier, it has transistors which may be BJT or FET type of transistors, and then resistors. So the general purpose operational amplifier are multi-stage systems. So it is having many stages like input stage, output stage, and intermediate stage. So the input stage will have 2 input terminals, output stage will have 1 output terminal, and the intermediate stage that will connect both the input stage and the output stage. And this is the diagram showing what is inside the operational amplifier. So first let's look into this diagram, and this is the symbol of operational amplifier with 2 input terminals, 1 output terminal, and two power supply terminals. Okay, positive power supply and negative power supply. Alright, the same has been expanded here. You see two input terminals. Okay, this is non-inverting input and this is inverting input. Okay, so this is the differential voltage, differential input voltage, and this box shows the internal structure of operational amplifier. This box shows the internal structure of operational amplifier, and in the internal structure you can see there is an input stage, intermediate stage, and then output stage. Okay, so these are the three stages inside the operational amplifier, and most of the components are transistors. So you can see this is the simplified diagram, so you can see a few transistors, but in the detailed diagram you can see many transistors. Okay, and this is the output terminal, and these are the power supply terminals. So the input stage is called as differential amplifier stage. Okay, so since there are two inputs, the difference of the inputs will be amplified and it has high input impedance. All right, then the next stage is the intermediate stage, which is called as a level shifter, which shifts the DC voltage level to a required value in order to bias the output stage. Okay, so it is a connection between the input stage and the output stage. Okay, and it allows the input signal to the output signal without any alteration, without any changes. Okay, right, then the output stage is called as push-pull stage, and this stage is having very low output impedance. Okay, so since it is going to act as an amplifier, it is good to have high input impedance and the low output impedance. Packaging of operational amplifier. The operational amplifier is fabricated on a tiny silicon chip and it is packaged in three ways. Okay, number one is the metal can package, and then dual inline package, and then flat packages. So the operational amplifiers are available in these forms of packages. Okay, and typical packages have 8, 10 and 14 terminals. Okay, so the most commonly used operational amplifier is MU-A741. So this is the diagram showing the types of packages. So if it is metal can package, it will be like this, and the dual inline packages will be like this, and the flat package will be like this. So these are the different this is the pictures of the packaging. So here we can see the numbering, the pin number of the packaging. Okay, so first one is the 8-pin metal can package. So in the metal can package there will be a tab. That tab indicates the 8th pin. Okay, so normally it starts from 1 and it ends at 8. Okay, and the numbering will be done in an anti-clockwise direction. If you see here 1, so this tab represents, or it is a reference. So from the tab we can move towards the left, and in the anti-clockwise direction it will be numbered like 1, 2, 3, 4, 5, 6, 7, 8. So this is in case of 8-pin metal can package. And the next picture is the 8-pin dual inline package. In the dual inline package there will be a reference at the top, and then we have to move towards left, and in the anti-clockwise direction the numbering will be done. Okay, you see from anti-clockwise direction 1, 2, 3, 4, 5, 6, 7, 8. Okay, and number 1 is the offset null, which we will see later. Number 2 is the inverting input, which we have already seen. Okay, there are two inputs. One is the inverting input, and another one is the non-inverting input, and that is pin number 3. And this is the power supply. V minus means negative power supply, that is pin number 4. And pin number 5 is again offset null. Pin number 6 is the output terminal. Pin number 7 is the positive power supply. Pin number 8 is not connected or no connection. All right, So pin number 2 and 3 are the input, pin number 6 is the output, pin number 4 and 7 is the power supply to the IC. Okay, right. So similarly, this is 14 pin dual inline package. So here is the reference mark, and if you move towards left, the numbering is done in the anti-clockwise direction, like 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So this is 14 pin package, okay, dual inline package. And the next one is 10 pin flat package. So here also there may be another reference, you see dot. So here there should be a dot here, so the dot should be placed here. So it depends upon the manufacturer. Okay, so starting from the left in the anti-clockwise direction, we can see 1 2 3 4 5 6 7 8 9 10, right? So that is how the numbering is done, and we should remember the input terminals, output terminals, the pin number for the input terminals, output terminals, and the power supply for the suitable connection. Manufacturer's design and specification of operational amplifier, right? So each type of operational amplifier has its own part identification number, okay, and that part identification number consists of 4 parts, like letter prefix, circuit designator, letter suffix, military specification, code. We will see one by one. Letter prefix is used to identify the manufacturer. Okay, it consists of 2 to 3 letters. So in this table you can see some of the manufacturers like Analog Devices, Burbron, then Cirrus Logic, Linear Technology, Maxim, Motorola, National Semiconductor, Texas Instruments, and this is the prefix for the manufacturers. So the National Semiconductor, they used to have LF, LM, then LMC, LMV. Okay, so you can see this in some of the IC you buy from the shop. And the second part is the circuit designation, and that circuit designation indicates the type of operational amplifier and its temperature, and it usually consists of 3 to 7 numbers and letters. Okay, so for example here we are having 324C. Okay, so the 324, it indicates the type of operational amplifier, and the C identifies the type of temperature. So there are 3 codes for identifying the temperature. C is for commercial range of temperature, I is for industrial, M is for military, and these are the operating range of temperature. Okay, operating temperature range. Letter suffix is the third part of a part identification number. Then it indicates or it identifies the packaging style, right? So mostly we'll be using the dual inline package, and the code, if it is D, then it is plastic dual inline for surface mounting on a PC board. Okay, if the code has J, then it is ceramic dual inline packaging. If it has N or P, then it is plastic dual inline for insertion into sockets. Okay, so this is how we can identify the style of the package. Okay, and the last part is the military specification code, and it is not for the commercial purpose, it is for high reliability applications. Okay, so if you want to design an IC for military specific applications, then that code will be captured. So this is the example part identification number, that is LM741CN. Okay, prefix indicates the type of manufacturer. So here LM is the prefix, and it indicates that the manufacturer is from a National Semiconductor. Okay, and the next part is 741C. Okay, 741 indicates the type of operational amplifier. So here it is general purpose operational amplifier, and the C indicates the temperature. So there are three ranges. This is C. So C means commercial, which ranges from 0 to 70 degrees Celsius. And the third part is the suffix, and here the suffix is N. So N means it is 8-pin plastic package. So dual inline plastic package. So that is how we have to understand the part identification number. And here there is no fourth part. The fourth part is only applicable for military specific application. So here there is no fourth part. Power supply to the operational amplifier. The power supply for the general purpose operational amplifier or bipolar power supply. So the connection for the bipolar power supply can be like this. You see, if the operational amplifier needs 15-volt power supply, okay, then it should be connected in series and 3 terminals should be taken out. So this is the positive power supply, and this is the negative power supply, and this is the common power supply. So in order to give power supply to the operational amplifier, these three terminals are needed. Okay, so if it is 15 volts, then you have to connect like this. If it is 9 volt, you can use this connection. Is same, is only the value is the difference. And there is also 12 volt power supply. Okay, right, this is the symbol and it is connected like this. You see, the positive power supply is taken from positive of the power supply, and the negative power supply is taken from a negative terminal of the power supply, and then the common power supply is used to measure the output voltage. So normally there will be, you need 2 terminals to measure the output. So one terminal will be connected at the output and another terminal should be connected to the common terminal. Okay, so that is how the power supply is used. The operational amplifiers can be connected in different ways for different application. Okay, so in general it will be in open loop. Okay, and then it can also be connected in a closed loop with positive feedback and negative feedback. Okay, so we can say if there is no feedback, then it is called as open loop configuration of operational amplifier. So this diagram is an open loop configuration because there is no feedback. Feedback means if the output is given to the input, then it is called feedback. So in this picture there is no feedback, and therefore it is called as open loop configuration of operational amplifier. And in these two pictures there is a feedback. You see, the output is taken and it is given to the input, and there are 2 inputs. One is inverting input and another one is non-inverting input. Therefore it is called as positive feedback operational amplifier, negative feedback operational amplifier. So if the output is given to the inverting input, then it is called as negative feedback operational amplifier. If the output is given to the non-inverting input, then it is called as positive feedback operational amplifier. Okay, that is it. In open loop configuration, the operational amplifier has very high gain. So the gain will be infinite. Okay, because of its high gain, the output voltage is either at its positive saturation voltage or at the negative saturation voltage. Okay, thus it can operate only in 2 states, that is either at positive V saturation or at negative V saturation. Therefore the operational amplifier in open loop act as a switch, like switch. Okay, so switch, it is having only 2 states, one is on state and another one is off state. So that is why we are calling it as switch. So that means it should have 2 states. Similarly, the operational amplifier is also having only 2 states, that is plus V saturation and minus V saturation. Therefore in this mode it acts as a switch. Okay, right, so here you can see the diagram and the operating regions. So you see, if V input is greater than V reference, okay, so in this picture this is the input and the input is given to the non-inverting terminal, and the reference is taken from the inverting terminal. Okay, so if V inverting is greater than V reference, then the output will be positive saturation. Saturation in the sense it is the power supply to the given to the operation amplifier, that is plus VCC. It may be 9 volt power supply, it may be 12 volt power supply, it may be 15 volt power supply. So after above that supply, it cannot produce output. So that is why the V saturation will be equal to this power supply. So here you can see saturation is equal to the power supply. Here also saturation is equal to the negative power supply. Okay, so in open loop configuration, the operational amplifier will be operating either in this region or in this negative region. It will not operate in this linear region. Okay, so that is the inference from this picture in this graph. Okay, let's see the demonstration in TINKERCAD. This is the picture from TINKERCAD. So what actually we are going to do in TINKERCAD is the open loop operation of the operational amplifier. So for that you should know the pin details of this IC741. So we are going to use this IC741 operational amplifier for the demonstration, and you should know about this pin number 2, that is the inverting input. Pin number 3 is the non-inverting input. Pin number 6 is the output. Then the power supply to the IC is pin number 4 and 7, that is a negative power supply and the positive power supply. Okay, all right, and this is what we are going to see in the TINKERCAD. And you should remember this formula. Okay, this is the basics behind the working. Okay, so if the inverting voltage is greater than reference voltage, then the output will be positive saturation. If the input is less than reference voltage, then the output will be in negative saturation. So we will see in the demonstration. Okay, so I'm here. Let's open a new page. Okay, so I'm going to create a new circuit for demonstrating the open loop configuration. So here is the new page. So let me change the name. Okay, so demonstration for open loop operational amplifier. All right, so I have changed the name, demonstration for the open loop operational amplifier. So we need, so here this is the toolbox. So I am going to select all, and I am going to search for breadboard. Okay, so I am going to take a small breadboard. So just drag and drop. Okay, so this is the breadboard. Then I need operational amplifier. So IC741. So here you have to connect the operation amplifier like this, and you see this is the identification. You see from the left, 1 2 3 4 5 6 7 8, there are 8 pins, and if you bring the cursor here, it will indicate its operation. Offset. Okay, pin number 2 is the inverting input. Pin number 3 is non-inverting input, that is IN plus. Then pin number 4 is the negative power supply, therefore it is showing power minus. Pin number 5 is offset 2. Pin number 6 is the output terminal. Pin number 7 is the positive power supply. Pin number 8 is no connection or not connected. All right. Okay, then we need power supply. Okay, bipolar power supply. So for that, let me take 9 volt battery. Okay, I'm going to rotate in this direction. Okay, so that the red indicates the positive terminal and the black indicates the negative terminal. So I'm going to buy one more battery in order to make bipolar power supply. So let me assemble the bipolar power supply. Okay, so this is positive, this is negative, and we have to connect the common terminal. So this one and this one connected together to make the common terminal. Alright, so this is the common terminal, and these three pins are the common terminal available for the connections. Okay, so this is positive terminal, this is negative terminal. So shall we give the positive power supply? So where should we give, like this is input, this is also input, this is the negative power supply. So here is the negative power supply, so I'm going to give this negative power supply to pin number 4. This is negative power supply, and the positive power supply is pin number 7. So this is the positive power supply. Okay, so positive power supply is given to pin number 7. 1 2 3 4 5 6 7. All right, so we are done with the power supply connection. Okay, so the next we have to give inputs. Okay, input. So I am going to give DC input. So for that I am going to choose power supply. Okay, so this is this will give the DC inputs. This is for inputs. Okay, this battery is for the power supply, and this we can name it as RPS, regulated power supply. This 2 is for giving the inputs. Okay, so pin number 2 is the inverting input, pin number 3 is the non-inverting input. So I am going to set, okay, I am going to set here it is 5 volt, and here it is also 5 volt. Okay, let me name this is the inputs. Okay, that is inverting inputs, and this DC power supply is for inverting non-inverting inputs. Non-inverting inputs. Okay, so the inputs are ready. This is inverting input and this is non-inverting input. All right, so I am going to set 7 volt for the inverting input, and I am going to set 5 volt for the non-inverting input. So I am going to give the connection. There are 2 terminals, so this terminal, it should be connected to the inverting input. So you see I have connected this to the inverting input. The other terminal should be connected to the common terminal. Okay, so this is the common terminal, and we are connecting that terminal to the common. So the input, one terminal of the input is given to the inverting input, the other terminal is given to the common. Okay, similarly here also we are going to give the input to the non-inverting terminal, and another terminal of the input should go to the common, and then that is the common. All right, so now you see inverting input is given to the inverting terminal, and the non-inverting input is given to the non-inverting terminal. All right, and the another terminal is given to the common. So now we have given the input, so it is left with measuring the output. So output is, we are going to measure the output voltage, and for measuring the output voltage we need multimeter. So here is the multimeter. So I'm going to drag and drop, and in this multimeter I am going to measure the voltage. So we can choose voltage, right, and the name, it can be outputs. Okay, right. So where is the outputs? So it is pin number 6. So pin number 6, so this is the positive. I'm going to give positive to the pin number 6 is connected, and another terminal of the multimeter should be connected to the common terminal, and this is the common terminal. Sorry, yeah, here is the common terminal and it is connected. Okay, so we have now done with the connection. Okay, so battery is given to the is the power supply for the IC, and these two are the inverting input and non-inverting input. So we have given DC input, and this is for the um, measuring the output. This is the multimeter. Okay, measuring the output voltage. So now we have to remember the formula or the rule. Okay, so you see this is inverting input, which is 7 volt, and this is non-inverting input, which is 5 volt. So which is greater? So 7 volt is greater than the 5 volt. Okay, so but 7 is connected to the inverting input, therefore the output should be inverting means negative input, so output should be minus V saturation. Okay, so here the V saturation is the VCC. What is the power supply? 9 volt. So the output should be minus 9 volt. Okay, so let's start the simulation here and let's check the output. Okay, so I have started the simulation. You see this is inverting input 7 volt, and this is non-inverting input 5 volt. 7 is greater than 5, and 7 is connected to the inverting input, therefore it is minus V saturation, that is minus 9 volts. Okay, so let's stop the simulation and let's verify the other way. Okay, let me give 5 volt to the inverting inputs, and I'm going to change, or I'm going to give 7 volt to the non-inverting input, and I'm going to start the simulation. So if I start the simulation, you see 5 volt is given to the inverting input, 7 volt is given to the non-inverting input, and 7 volt is greater than this uh, inverting input. Therefore, the output should be positive V saturation. Positive V saturation means what? It is 9. Okay, plus VCC is 9 volts. Okay, so that is the operation, and whatever the value, the output will be either positive V saturation or negative V saturation. In this case, either plus 9 volt or it will be minus 9 volt. So you can change, even you see you can change 5.01. This small change, you see 5 volt to the inverting input, 5.01 to the non-inverting input. So which is greater? 5.01 is greater, therefore it will give positive V saturation, that is positive V. So if I change 5.02, then it will go to negative V saturation. So that means you can understand the two state of operation, either at plus V saturation or at minus V saturation. All right, so there is one more case, that is if both are equal, then it will be 0, because we know that if both are equal it will be 0, because it is a differential, the input stage is the differential amplifier stage. So what is the difference? The difference is 0, so the output will, of course, it will be 0. Okay, all right. Closed loop configuration of the operational amplifier. So when the output is given back to the input, then it is called as closed loop configuration. So the gain of the closed loop configuration of operational amplifier can be controlled, whereas in open loop the gain is infinite, whereas in the closed loop here, in closed loop the gain is controlled. Okay, and the circuit behaves in a linear manner, so it can be operated in a linear way. All right, so that is the advantage of this closed loop configuration. So you can have a controlled outputs. Okay, right, there are two types of feedback. One is positive feedback and another one is negative feedback. So in the first picture, the output is given back to the positive input, that is non-inverting input. So if the output is given back to the non-inverting input, then it is called as positive feedback operational amplifier. Okay, and in the second picture you can see the output is given back to the inverting input, that is the negative terminal. So hence it is called as negative feedback amplifier, operational amplifier. All right. Positive feedback operational amplifier. If the signal feedback is in phase with the input signal, then it is called as positive feedback. The positive feedback aids the input signal and it is also called as regenerative feedback. Basically, this positive feedback is essentially used in the oscillator circuits. All right. Negative feedback operational amplifier. If the signal feedback is in opposites or out of phase by 180 degree with respect to the input signal, then the feedback is called as negative feedback. So here you can see the input and the output. There is a phase shift by 180 degree. Okay, that is the negative feedback amplifier. And this negative feedback amplifier has a self-correcting ability which changes with the change in environmental conditions. Okay, and this negative feedback operational amplifier is also called as degenerative feedback because it controls the output voltage and also the gain, voltage gain. So here is the comparison between positive feedback and negative feedback operational amplifier. So the positive feedback operational amplifier is also called as regenerative feedback, and the negative feedback operational amplifier is also called as degenerative feedback. Okay, and the relation between input and output is in phase in positive feedback and it is out of phase in negative feedback. Okay, and then the overall gain of positive feedback is greater, whereas in negative feedback it is smaller. Okay, smaller than the gain of the system. Then the effective inputs of the positive feedback operational amplifier is the sum of the applied input and the feedback signal, whereas in negative feedback it is the difference of the applied input and the feedback signal. Okay, and the stability of the positive feedback is comparatively lesser than the negative feedback, whereas in negative feedback the stability is higher. Okay, and here in positive feedback the phase shift can be either 0 degree or 360 degree. Okay, normally it is in phase. Okay, and whereas in negative feedback the phase shift will be 180 degree. Okay, the phase shift of 180 degree can be achieved. Then in positive feedback operational amplifier the feedback is taken from the non-inverting terminal of op-amp, whereas in negative feedback operational amplifier the feedback is taken from the inverting terminal. All right, then the sensitivity of positive feedback is comparatively lower, whereas the sensitivity of negative feedback is higher. Then the positive feedback is mainly used in oscillator circuit, whereas the negative feedback is mainly used in amplifier circuit. So these are the differences or comparison between positive and negative feedback operational amplifier. Thank you.